Hello and welcome to the Perclipse tutorial. My name is Lukas Lewandowski. I'm working for the Distributed System Group at the University of Constance, Germany. I'd like to give you an introduction in the Perfidix Eclipse plugin Perclipse. First of all, let's talk about the aim of Perclipse. Perclipse is a Java benchmarking tool and designed similar to the junit 4 plugin. But the objective is not testing your Java methods for functionality like junit. It focuses on the benchmark possibilities. So, if you want to measure your Java methods, for example for time duration or storage allocation, Perclipse is the tool you can choose for that. Another advantage is that you can bench several methods to compare the performance between your implementations and choose the best one for your productive code. Now let's talk about how to get the Perclipse plugin. In Eclipse you have two possibilities to install the plugin. You can download the feature from sourceforge.net, or you can use the preferred way, the Eclipse update side mechanism. So you go on install new software, you add the site here, I did that before, you choose the plugin and then you install it. The Perclipse plugin underlies the Apache license 2.0 and requires Java 6 for use. After installation it is easy to use the Perclipse functionality. To show this, I created an example project, the sum project. It contains of two packages, the main package and the test package. The test package contains test cases for the functionality of the main package sources. The main package has two classes. They have both two sum methods, you can see it here, that make an addition of all numbers until a max value is reached. In this normal sum, we do that in a for loop. In a short sum, we do not need a loop, but we have to do a multiplication and a division. So, if we go on the right, run as unit test, you can test your Java methods if they are working as you expect. But what we cannot do is to bench it. We don't know which one performs better, the short sum or the normal sum. To reach that, we have to create a new package. We name it bench. We write a new class, for example the compare sum. And like in JUnit, you have to write void methods for that, for the bench process. Let's name it bench normal. And bench short. Okay, within the methods, we take an instance. Of each class, and call the method. For example, we want to make an addition until 100,000. Okay. The same we do in the add method for the short sum. New short sum. Okay, and here we call the sum method to the value of 100,000. Okay, what we have to do that we can mark these methods, that they are bench methods, we just have to do an annotation like in JUnit, but we name it bench. The proposal manager offers us the add Perfidix library to the build path. We do that, and you can see on the left side in the package explorer that the library was added. Then you have just to import it with Command-Shift-O, for example, and you can use that. We do the same for this method too. Okay. Now we are ready to start it. Right click on the project, run as Perfidix bench. Yeah, you can see a new view here with the progress bar, the counts of the whole runs, the error count, and the methods that are under bench control, this two. And as you can see, there are by default 10 runs for each method set. In the console, you can see the output of the results. So you see the units, the sum of the runs, the minimum, maximum, average, and the standard deviation, and so on. Okay, you can specify another value for the runs for each annotation. For example, 44 for the first one. If we start again, you can see it here that we have 44 until before. Okay, but we can set also the default values. So for that we just have to create a configuration class. For example, my config class that extends the abstract config of Perfidix. You can see it here. Okay. We can set 5 parameters. These are just the 5. The run value that was set with 10 before, we set it now to 33, for example. The abstract meter is the meter that is under measurement. For example, the time meter we had before, with time in milliseconds, and for example a memory meter here with byte, for example. We have the output, for example the tabulary output, the tabulary summary output that we have in the console. Tabulary summary output, yes, and the kind of arrangement. And there we can choose no arrangement, that's the default setting, so we can see it on the left side. First, this method was benched 44 times, and then this method was benched 10 times. And if you select here in the arrangement, for example, sequential method arrangement, the method will change after each run. So first, in the first run, this method will be benched. Afterwards, this will be benched in the second run, and this in the third run, and the fourth run. It changes every run. And the shuffle arrangement is just a random shuffle arrangement, so you never know, it's more realistic. We choose that one, for example. The GC prop field specifies if the garbage collector is called after each run or not. With the value of 1, 0, it is called. If it's 0, it's not called after each run. What we now have to do is to write a public constructor, my config class, which calls the super constructor with the values we specified above. Yeah, the output, the arrangement, and the garbage collector. Alright. Okay, the only thing that is still missing is to mark our class as our configuration class. So we do that with the annotation add benchmark config. It's this one. We save it, and now we can start it again at Perfidix bench, and you can see it here. It's a shuffle arrangement, the jumping first here and then maybe to here and so on. You can see that the default value for the runs is set for 33 to each of the bands. And the summary output, you can see it here, is set to 2 units. It's the bytes, the memory meter that we had set, and 2 milliseconds, it's for the time meter we set before too. Perclipse offers to write, like in JUnit, setup or teardown methods. and you mark them with annotations too, for example with the add before each run or add before first run, and the teardown methods you can declare for the class for each run or for last run, for example. Okay, thank you for your attention, and I hope you enjoyed this Perclipse tutorial. You can find additional information about Perclipse on the project website perfidix.org or on the SourceForge website. The Perclipse update site is available under Perfidix desi-inf unit constant/update site. And now it's your turn. Bench your Java code.